So today we will go through the example 4 of the chapter 8 of quadrilaterals. So it's an important question as far as exam is concerned. So the question is, two parallel lines L and M are intersected by a transversal P. Two parallel lines L and M are intersected by a transversal P. Now we have to show that the quadrilateral formed by the bisectors of interior angles is a rectangle. So we have four interior angles, this and this. So the bisector of them are forming a rectangle. We have to prove that. So we have this interior angle, we have this interior angle, we have this interior angle, and we have this interior angle. Now the bisectors of them are forming a rectangle. We have to prove that. So we will draw the bisector. Let this is the bisector of this. This is the bisector of this. This is the bisector of this. And this is the bisector of this. Now look. This total angle is equal to this total angle, because these are alternate interior angles, and when the lines are parallel, alternate interior angles are equal. And then half of it will be this, half of it will be equal to half of it. So these two angles will be equal. So these are again forming a interior opposite angles. So these two lines will be parallel. Similarly, when we consider these two angles, these two angles like this equal to this alternate interior opposite angles, half of this is equal to half of this. So this will be equal to this. So this will be parallel to this, and it will be proved that it is a parallelogram. Then we have to prove any one angle equal to 90 degree. So this total angle plus this total angle will be a linear pair. Then half of this plus half of this will be equal to half of 180. So this angle will be 90 degree. So let us go step by step. So let A, B, C, D will be the quadrilateral formed. We name it as E, F, G, H. Now we will go step by step. So what we are given, that L is parallel to M and P is the transversal. P is the transversal. So what we have to prove? We have to prove that ABCD is a rectangle. Is a rectangle. So proof. So angle EAC, angle EAC is equal to angle GCA, is equal to angle GCA, because these are alternate interior angles. Now half of EAC is equal to half of EAC is equal to half of GCA. Half of GCA, we are multiplying half on both sides because we are interested in the interior angles inside the quadrilaterals. बाहर वाला हमको नहीं चाहिए. So half of EAC, this is not required. Half of EAC, we don't require this angle, we only require this angle. So in place of half of EAC, we will write angle CAB, angle CAB, and half of GCA we will write angle DCA, because we want to come inside the quadrilateral ABCD. So DCA. But these are forming interior opposite angle. So we can write, but these are interior opposite angles. Therefore what will happen? Therefore AB will be parallel to CD. Therefore, AB will be parallel to CD. Question number 1. Similarly, when we take angle HAC and angle FCA, we can prove that AD is parallel to BC. AD is parallel to BC. When we give the detailed proof for one side and when we write similarly, we do not have to prove for the second side. We can directly just simply write that similarly taking this and this is parallel to this. So this forms the equation number 2. So from 1 and 2, from equation 1 and 2, what we get? Opposite sides are parallel. Opposite sides are parallel. So ABCD is a parallelogram. Now we have to prove that ABCD is a rectangle. Now we have reached that ABCD is a parallelogram, and we know that any parallelogram whose one angle is 90 degree, it is a rectangle. So to prove one angle is 90 degree, we need to take two adjacent angles. So here it is a straight line. So angle GCA plus angle FCA is equal to 180 degree because they are forming a linear pair. So angle GCA plus angle FCA is equal to 180 degree because they are forming a linear pair of angles. Now we want to make it as 90 degree. We want to come inside it. So half, we are multiplying half on both sides. So half of GCA plus half of FCA is equal to half of 180 degree, which is nothing but 90 degree. Now in place of half of GCA, we are not interested in this angle because this is outside the quadrilateral ABCD. So we require this angle. So in place of half of GCA, what we will write? Angle DCA. Angle DCA. Plus similarly, in place of half of FCA, we will write ACB because we are not interested in this. ACB, which is equal to 90 degree. But half of DCA plus ACB, it is forming angle C inside the quadrilateral. So angle C is equal to 90 degree. Now if we take it as equation number 3, and if we take it as equation number 4, so from 3 and 4, what we get? ABCD is a parallelogram and one angle is 90 degrees. So it is a rectangle. So from 3 and 4 we get ABCD is a rectangle. Hence proved. Thank you.